We're going to start with a fairly simple exercise using skills that almost everybody has when they come in to a pre-calculus course. If you don't have this skill, you're going to pick it up real quick. Although if you don't have the skill, I'm a little concerned about what other skills you might be missing. We'll see in the first week or two how all that shapes up. In any case, first instruction. Now this is interactive. You have to do this. You don't just sit there and watch. You take a piece of paper and a pencil or a pen, and you are going to sketch stuff. Okay, you don't have to make publishable quality sketches. You just slop down pretty much anything at this point and still get the idea. Now there are ways you can screw it up, so try not to. But I don't think that's going to be a big issue. So the first thing I want you to do is sketch a set of X-Y axes. Well, let's just start with that. Sketch a set of X-Y axes. Now pause the video and sketch a set of X-Y axes. You don't have to mark it off yet. You don't have to mark the scale on it yet, but just go ahead and sketch it. Now, hopefully you've done that and your X-Y axes look something like this. Now, this is fundamental knowledge, and I think everybody can be expected to have. If you don't have it, well, if you've never seen this before, and if you don't recognize it after seeing it, even if you couldn't do it at first, you better talk to me a little bit, okay? And it's not, I'm not, you know, I want to probe and make sure that you're ready for this course, okay? And if you've not seen, if you don't understand this, at least after seeing it, it's questionable whether you're ready for this course. Okay, so anyhow, there's sort of X-Y axis. Now we want to mark the points -2, 0, 2, 0, -2, 4, and 2, 4. So you're going to want to put a scale on this axis. You're going to want to mark little tick marks that go at least as far as -2 and +2 on the x-axis. Of course, this is the x-axis, and this is the y-axis. Again, you should understand this after just saying the instruction, and if not, then certainly, hopefully, you'll understand it after I draw this. So you need to pause again and do this. So, okay, now I'm assuming you've paused and you've done it. I'm going to scale off the x-axis like so. I'm going to put 2 here. And then, of course, -2 would have to go over here at an equal distance on the opposite side of the x-axis or the y-axis, so that the y-axis is halfway between -2 and 2. I think maybe this is a little too close. Yeah, probably. But anyhow, you get the idea. And again, if it's not totally precise, it's okay at this point. We'll learn how to do this more precisely. Now I'm going to take the number halfway between 0 and 2. That's going to be 1. Halfway between 0 and -2 is -1. Okay. Then on the y-axis, I'm going to need 4. Okay, so I'm going to put 4 up here. And I'm going to divide the interval from 0 to 4 in half. And that's going to be 2. And I'm not even going to mark that. We know that if it's halfway between 0 and 4, it's 2. And then halfway between 0 and 2 is going to be 1. And halfway between 2 and 4 is 3. So there's a reasonably well marked axis. Now, when I mark this axis, 4 units here is equivalent to about 3 units down here. Now, ideally, I would have made the y-axis, I would have put 4 up a little higher, so the distance of 4 here is the same as the distance of 4 here. But it really doesn't matter. As it turns out, in the long run, there are many applications that we have to do where the y-axis has totally different types of numbers than the x-axis. We still want our graphs to look like something, and we have to use different scales for the y and the x-axis. So actually, we've got a bit of a different scale for the x and y axis. We'll see what that does. Okay. Now we want to mark the points -2, 0, 2, 0, and so forth. Okay, now if you didn't know how to set up an X, Y axis, there it is. Make sure that yours looks something like this. And can proceed to mark these 4 points. If you haven't already done so. Okay, you should have paused and done it. If you hadn't done it already, you might have done it already. You might have even read this instruction and done the whole thing, in which case you can probably skip forward a little bit. But there are things you might want to understand, side comments that I make that might be valuable to you. Anyhow, here's the point. -2, 0. The first number tells you the X coordinate, the second number tells you the Y coordinate. So here X is -2 and Y is 0 because Y is 0 everywhere on the X axis. Okay, and while we're on -2, let's stick with -2. And let's do the point -2, 4. Now the point -2, 4 lies on the line for X equals 2. This is a line where X, sorry, -2. This is a line where X equals -2. The X coordinate of every point on this line is -2 because any point on this line, if we go directly back to the X axis, we're going to get -2. And the Y coordinate is 4. Well, let's be specific about this. Let's sketch the line where Y equals 4. Now, you might not have sketched this line and this line. You might have just put a point up here and maybe a little line here and a little line here, projection lines for the 4 and the 2. And that would, that's perfectly okay. I'm going to do it this way because I kind of like the way it works out. Okay, now we want to locate the point 2, 0. Well, X is 2, so I'm going to, a little overkill, but it's okay. I'm going to do the line here where X equals 2. And of course, the line where Y equals 0 is just the X axis. So the point with X coordinate 2 and Y coordinate 0 is here. And the point 2, 4, X coordinate is 2, Y coordinate is 4. I've already got that point up here. Okay, very good. Now, again, you want to understand everything I just did and understand everything I just said. But you didn't have to do every detail of that, as long as you have a set of X and Y coordinate axes with 4 points marked in about the right position. With this point, you get the same height as this point, and this point directly below this point directly below this, or close to directly below. I think I draw a straight line down here, and I kind of missed too, but that's okay. Okay, now, even if your graph isn't perfect, you're going to get the idea. Okay, now we want to connect each point with a straight line to the point or points closest to it. So can you proceed to do that? By each point, I mean each of these 4 points. I didn't want to put too many words here, although it would have been correct to say each of the 4 marked points. Okay, but we connect each point with a straight line to the point or points closest to it. Can you do that? Again, should have paused and done it. Okay, so I don't know which point you want to start with. We'll start with this one. I'm going to connect this point to this point. I'm going to use a slightly different color. And I could have also connected this point to this point because I got 2 points that are closest to this one. We wouldn't mark from here to here because this point is clearly further from this point than either this one or this one. Now, when I say closest, I don't necessarily mean the closest the way you have a graph, you have different scales. Well, we'll get into that later. Never mind. Okay, so this works. And then connect this point to this point because it hasn't been connected. And then this point to this point. Now, every point is connected by a straight line to the points closest to them. Now, and when I say the points closest to it, I could have said it like this. I'll say the points 4 units away from it. Because of course, if you think of by closest, the way I've drawn this point is closer to this one than this point. So you might not have marked this. And this point is closer to this one than it is to this one. So you might not have marked this. If we say each point with a straight line, 4 units away from it, well, it's 4 units from here to here. It's 4 units from here to here. 4 units from here to here. Make sure you understand that. Okay. So that's quite straightforward. Now we'll go on with one more instruction. Okay, the next thing I'd like you to do is sketch the parabola through the points -2, 4, 0, 0, and 2, 4. So if you sketch a parabola through those points. I don't assume that everybody knows what a parabola is. I think most people do. If you have the prerequisites for this course, you've almost certainly seen parabolas. If not, it's okay. You'll see one in a minute and you'll understand. Okay, so hopefully you've paused and done that, or you're sitting there scratching your head wondering what a parabola is. And either way, it's fine. Okay. -2, 4. Okay, well, let's just put a big old dot on the point -2, 4, and on the point 2, 4, and on the point 0, 0. Now the parabola has to go through these 3 points. Now, we could draw a straight line from here to here to here, and we go through the 3 points. And if you do the straight line from here to here to here, I'm okay with that right now. Then we're going to modify that. You're going to learn soon how to draw a really good parabola. It's freehand. And you're going to be surprised how well you can do that. Probably better than I can do, because I always get them lopsided. And I'm probably going to do that here too. Okay, well, I'm going to cheat a little bit. You won't know this. Maybe you do. Parabola has to go through this point and this point also. So now I can use these points to guide myself, make a pretty good parabola. That's better than I usually do. And if you want to cheat and make it your parabolas, I just went through the point -1, 1. And the point 1, 1. And that's through those points also. You're going to learn that and much more about parabolas again within a couple of days. Okay, so here we've got this parabola. Okay. All right. Now what I want you to do is let me write out the instruction. As soon as I decide for sure what I want you to do, because I'm debating here. Okay, my debate's over, and I'm glad I stopped to think about it. I think what I'm doing here is maybe a pretty good idea. Okay, there's 8 units. And okay, now between -8 and 8, I go halfway, I get 0. So I want you to do this, okay? And then between 8 and 0, I get 4. Halfway between 4 and 0, I get 2. Now, can you do the same thing I just did on the opposite side of 0, between 0 and -8? Pause and please do exactly what I did, an exact analogy of what I just did. Okay, hopefully you've done that. Okay, between 0 and -8, we cut that distance in half, we get -4. We cut this distance in half, and we get -2. Okay, so I've got a nicely scaled x-axis. Now, if you absolutely feel like you have to put 6 in here and -6 here, and maybe we're eventually going to do that, it's okay, but we don't need it just yet. So we're going to leave it out. Okay, then I come up here. And I sketch my y-axis. And 8 units is this far, and that puts it up here. So 8's about up here. Now, the 8 and the marking and the Y and everything kind of get a little crowded because I should have made this axis a little lower, but so be it. Okay, there's 8, and now we divide that in half and we get 4. Divide this in half and we get 2. And at that point, at this point, we probably got enough. Okay, at least enough to get started. We can always fill in markings. You know what? What I did there was really dumb. The distance from here to here is 16, isn't it? The scale just didn't look right. Okay, so while I was debating, apparently something happened to my ability to pay attention. A little mistake there. Okay, I want to put 16 up here. And then because distance from here to here is 16, so that should be 16. Okay, half of that is 8, half of that is 4. And half of that, of course, is 2. I'm not going to mark the 2, but we get the idea. If my 2 is a little bit high there, it should have been a little bit lower. Still close enough. And now it's all messed up. Okay, that's fine. There's 4 units. There's 4 units. That looks about right. Now we're going to make the same square. This is actually a square if you use equal scales. Since I've got equal scales or more or less equal scales this time, probably fairly close to having a square. Okay, well, I've got to go up to this point. And since my marking of the 4 is going to interfere with plotting the point, I'm going to erase the marking. We understand this is 4. Here's 2. So here's -2, 0, -2, 4, 2, 4, and 2, 0. And here, pretty blue. Is the square, even though it looks more like, it doesn't look that much like a square. It's the square we drew here, but it's on a graph with a bigger scale. Now we could also throw in a parabola, and we will eventually, but let's just stick with the square. Okay. Now what I want you to do, and let me write it out, just so you don't have to watch me write it. Okay, so I've drawn, I've drawn the fundamental square here. I want you to move the fundamental square. Here the position of the board. I want you to move the fundamental square so that the point -2, 4 moves to the point 4, 4. Now you got to move the whole square, but I've told you where one point goes. One point goes from -2, 4 to the point 4, 4. Okay. We're not going to change the shape or the orientation of the square. In other words, you don't want to rotate the square. You really don't want to do that. Because that gets really complicated. Okay. You want to keep it square. You just want to shift it so that this point goes to this point and all the rest of the square goes along with it. So it's like you grab the square by that point and you move it wherever it's going to go. So take a second and see if you can do that. Okay, now hopefully you have, but let's just work on this a little bit. Okay, we have the point -2, 4, which is right here. And we want this point to move over to the point 4, 4. Well, it should be pretty clear. How far did we stop and think? How far did we move the point and in what direction? Well, you should be able to answer that really quickly, but maybe not. If not, just be sure you understand my explanation here. I'm gonna draw a little arrow here that indicates how that point moved. It moved from here to here. Now, officially, this arrow should start right on this point and end right on this point. But I've had to draw it a little higher because I don't want to mess up my original square. Okay, so the point goes from here to here. How far did it move? It moves 6 units. From -2 to 4, 6, and count. So I'm going to put a +6 on top of this arrow. I'm going to put a little arrow over the +6 because it tells me what direction. And so, well, that little arrow might not be a good idea. There it is. Okay. So we move +6 units. Don't worry about that little arrow over the 6. We'll see that later. Now, how's this point going to move? Okay. Well, think about it. Pause if necessary, but it should be clear that this point is also going to move +6 units in this direction, because if it moves any other way, well, okay. Let's think about this. This point is directly below this one. We're going to have a point directly below this. That's 4 units below. Okay, this point is 4 units below this. So when this point moves, it's going to have to end up 4 units below this one, which is going to be right here. So now we've got a second square. And right there's one of its sides. So this whole side moves over 6 units. In fact, every point is going to move over 6 units. This point will move over 6 units. You think of where that arrow would go from here to here. And this point will move over 6 units. So that we're going to end up with a point here and a point here. There's our square. It's been moved. We haven't changed its shape. We haven't changed its orientation. We haven't rotated it, in other words. And here's our new square. Okay, every point, every corner of this square moves over 6 units this way. Now, what are the coordinates of these points? Well, pretty easy. We add 6 to -2 and we get 4. It moves in the horizontal direction, so the y coordinate doesn't change. So that the coordinates here are going to be 4, 4, which is exactly what we said. So if this point moves to the point 4, 4, it has to move 6 units in horizontal direction. Again, what terminology? The x-axis is horizontal, y-axis vertical. Okay, you want to get that terminology right. Okay. On the point 2, 4 moves to 1. If you move 6 units, you're at x equals 2, 6 units gets you to 8. Okay, you could even say, okay, this point will be 2 plus 6, 4 equals 8 there. And then it's pretty obvious what these points are, but we do similar with it too. Okay, so we got 8, 0. And here we've got 4, 0. I don't have a good place to label that, so I'll just kind of leave it for it. All right, so all we've got, we've moved the square. Here to here. Now I'm going to ask you to do another move, and I'll pause the video while I write this down. Okay, I've had to kind of redraw my diagram because I didn't have a good place to move this thing to. Okay, kind of cluttered everything up here. So if yours isn't cluttered up, you can just use the diagram you already have. So whether you have to reconstruct this or not, go ahead and sketch what happens if we move the fundamental square so that the point 0, 0, which is on the square, moves to the point 3, 6. So pause. Do that. Okay, hopefully that's done. Okay, well, we mark the point 0, 0, right there it is. And then I want to find the point 3, 6. Well, we know that this is 4 here, and this is 2 here, which means that 3 is going to go right about here. And then, of course, we can draw this line and call that the y equals 4 line. And y is 4 here, 8 here, so y equals 6 here. Here's our y equals 6 line. And then here is our line for x equals 3. Not particularly straight, not particularly well drawn, but we get the idea. Okay, so we want this point to end up here. Now, in order to do that, we've got to move this point 3 units to the right and up 6 units. Well, there are a couple of ways we can do this, but we can take every corner and move it 3 units to the right and up 6. So this corner is at 2, 4. So I'm going to kind of list where these points go. Okay. I'm going to just indicate this with arrows. Every point goes 3 units to the right. And 6 units up. So for example, -2, 4 moves to -2 plus 3. 3 is irredeemable. Let's see if I can write it a bit more clearly. -2 plus 3. 4 plus 6, which is 1, 10. Might be hard to read that 10, but it should be clear. Okay, if we move it, it's y equals 4, it's got to move up 6 units, it's going to end up at y equals 10. And of course, if we're moving up 6 units, that means we add 6 to the y coordinate. If we add 3 to the x coordinate, we're going to get 1 because the x coordinate is -2. So this moves to the point 1, 10. Now 1 is here. So let's just go ahead and draw the x equals 1 line. And y equals 10. Now here's 8, here's 16, halfway between 8 and 16 is 12, halfway between 8 and 12 is 10. So here's a line for y equals 10. And it occurs in my shoulders probably blocking it. So I'm going to move this board over to the floor. Okay. So anyhow, we've located y equals 10 here. Halfway between 8 and 16 is 12. Halfway between 12 and 8 is 10. There's y equals 10. And here's the x equals 1 line. Halfway between 0 and 2. I didn't label that. I guess I could put 1 here and an arrow to that mark on the other side. Okay. So now we have this point corresponds to this. This point is moved over 3 and up 6. This point will move over 3 and up 6. So that 2, 4 moves to 2 plus 3 4 plus 6, which is 5. And you know, if we're going to locate 5, 10, there's 4 and there's 8. Halfway between 4 and 8 is 6. And halfway between 4 and 6 is 5. And here's 5, and here's the line where x equals 5. The vertical line, not very well drawn here, but x equals 5. So there's x equals 1, x equals 3, and x equals 5. Mark a point here. And yeah, scale's kind of a little bit screwed up, but so there. Okay. Well, we do the same thing with the point -2, 0. We add 3 to the 0, and we get 3. And we add 6 to the 0, and get 4. That would get 6. And we end up with a point here, and a point here. Here's our square. Again, these vertical lines, this line kind of gets a little bit crooked. But right there's our square. And we know what the coordinates in the corners are. All right, now why are we bothering to do this? Well, partly because we want to get familiar with coordinates and some of the things we do when we're dealing with coordinates on an XY set of axes. And partly because, well, I'm just going to say this. Can you draw your parabola inside of each of these squares? Okay, in other words, I can draw the parabola here. Not a very good parabola. Just flatten out a little more, but see here. And okay, when I draw the parabola over here, I'm going to draw a dotted line. I don't have to label, but it goes through the center, vertical line through the center of the square. Because that helps me locate where the vertex is. And you don't necessarily need to know the terminology. And that's still a little bit lopsided. It's too short here. Well, there it is. There's my best attempt at drawing this parabola. Okay. Ideally, the parabola should be, this side of the parabola should be a reflection of this side. It's like a mirror image. We'll get to that later. Okay, so can you draw the parabolas here and here? Okay. Let's see, the parabola here. Let's go to the corners and so forth. And you have this. Then if I draw accurate line through the center of this square, that parabola is going to look something like this. Okay, one more thing, and then we'll wrap up this video. This parabola is the graph of the relation for the function in which y equals x squared. Okay, for example, if x is -2, x squared is 4. If x is 2, x squared is 4. So the point -2, 4, and 0.24 lie on this parabola. If x is 0, 0 squared is 0, so y equals 0. So equals 0 on this, the point 0, 0 is on this parabola. Now, there are other points, and the parabola is not totally accurate, because this is a hand sketch graph. All right. This parabola also has a formula, but it's certainly not y equals x squared, because this parabola doesn't contain this point, or this point. Now, let me give you a hint as to what we might do here. Actually, I'm just going to tell you. It turns out that, of course, this parabola is also y equals x squared. And I guess get the whole thing on here. Okay, there's your y equals x squared parabola. This parabola is y equals quantity x minus 6 squared. We'll say more about this in another video, make a little more sense of it. This parabola is y equals x minus 3 squared plus 6. Now, we moved this parabola over 6 units, and we got y equals x minus 6 squared. We haven't verified that. We will, but in another video. Here, we've moved this parabola over 3 units. That gives us in the x direction, so it's y equals x minus 3 squared. Okay, moving 6 units horizontally, we get an x minus 6 squared. Moving 3 units horizontally, it's an x minus 3 squared. And then we move it 6 units off, which makes all the y coordinates 6 greater, and we get the plus 6. Okay, this is very important, and it's something that people have a lot of trouble with. So we want to start with just taking a square and moving it around in the XY, which is fairly straightforward. I think everybody should understand this pretty well. So if I tell you to move the original square 4 units in this direction and 8 units down, you'd be able to do it and tell me what the corners are. Okay. Understanding this takes a little bit more, and I'm going to give you a little more explanation of that, but we won't do it in all its gory detail for maybe another week or two.